Welcome everyone to the Passive House Accelerator's third Global Passive House Happy Hour of our second year and episode number 55. Thank you for joining us. I'm Prudence Ferreira, Senior Member of the Carbon Neutral Design Group at BR+A Consulting Engineers, and I lead their Passive House team. This gathering that you are now part of welcomes everyone, no matter what you know or what you don't know or why you're here. You're in the right place. We share all kinds of good, juicy tidbits about anything with the letters PH in it, about building science, zero energy, zero carbon, electrification, and retrofitting our built environment to reduce GHG emissions. So, in zero carbon building news this week, a few fantastic wins have happened over here in the US that I wanted to share with you all. You may have heard that Biden rolled out an infrastructure spending plan that's set to invest $213 billion towards building, renovating, and retrofitting more than 2 million homes and housing units. And the plan would also build and rehabilitate more than 500,000 homes for low and middle income home buyers specifically. And the upgrades would be paid for through block grant programs, efficiency tax credits, and weatherization assistance. And then also, Biden wants to allocate $100 billion to workforce development, specifically for helping dislocated workers out of work from COVID, assisting underserved groups, and getting students on career paths before they graduate high school. How about that? 40 billion of that would be spent on retraining dislocated workers, specifically in high demand sectors like ours, like clean energy. And then 48 billion of that would go into apprenticeships, career pathway programs for middle school and high school students, and job training programs at community colleges. Meanwhile, in Massachusetts, Bill S9, known as the Climate Bill, finally passed after being vetoed like 4 times and sent back to the state Senate. And through all the multiple revisions, the mandate for a net zero energy code for the state stayed intact. And I'm thrilled that the firm that I work for, BR+A, is part of the small team working with the Massachusetts Department of Energy Resources to actually write that code. And the first draft is due out in September, which actually follows the same timeline as ASHRAE 227, the passive building standard. Also, one last thing, ASHRAE 228, which sets a standard method for evaluating zero net energy and zero net carbon building performance, is out for its first public review. I'm going to add a link to the chat so you can take a look at it and comment. And the reason why it's important is because we haven't had anything like this yet to clearly define and to give language that we can all use in common. And ASHRAE 227 will be referring to this standard as well. So a lot of positive momentum. And I know not all of us are from the States or even North America, but I wanted to share it because to the extent we inform ourselves, we can help put peer pressure on our own elected officials in our own communities and serve as resources for the development of new codes and standards where we live. So I'd like to invite you all to unmute yourselves and join me in opening the show with a toast to the intersection of building science and civic action.
You're here.
You're here.
All right. So if you're not already in the game and you're watching from the sidelines, we need you to get in there, guys. Go to town meetings, start petitions, rally local architects and engineers to sign on, saying they are ready for Passive House path to net zero and carbon neutrality. And bring it to your elected officials with a proposal. All right, so let's go ahead and settle in, get ready for a great show tonight, today, this morning, wherever you're at. We've got Micheel Wassouf with us, joining from Spain to talk about an exciting school retrofit project. But first, we're going to check out a Spanish version of the Ice Block Challenge in Barcelona that Micheel actually voiced over, especially for us in English, just for the Accelerator.
Micheel Wassouf from Energiehaus. Here you can see a video we have made during an ice cube bed we have organized some years ago. It was organized also with the German Chamber for Industry. And you can see here some details of preparing the box. Normally we use the box which is used for storing liquids, and there we have put these thousands of liters of hard frozen ice, let's say 1 ton of water, and we have exposed this energy, let's say, during 2 weeks in July in harsh summer conditions in Spain. So we wanted to see how many of this ice survived after these 2 weeks. We had temperatures till 38 degrees. We have done this ice cube bed several times in Spain, not only in Barcelona. Here you can see the ice. It was not so easy to find a firm which prepared us these nice cubes of ice. Here you can see also some details of the construction. We collaborated with wood constructor from the region, which was quite experienced with passive house construction, so he knew the importance not only of a high insulation of the thermal envelope, but also of the air tightness, which is really crucial for this kind of ice cube beds. See the details how they are installing this ton of ice. You can also see in my hand a data logger, because we wanted to know the temperatures inside of the box. We had this connected with the server, so we could see also the temperatures on real time, actually, from the beginning and during all these 2 weeks of exposure of the ice cube bed. We had about, as I remember, about 6 degrees below zero, constant temperature, because of course the energy which comes in through the thermal envelope didn't raise the temperature inside, but only contributed to this phase change of the frozen ice to water. No? This bed has been organized by our firm, or by Energiehaus, and we of course needed the collaboration of firms who are manufacturer of components of passive houses. Here you can see some images of the ice cube bed. And at the end, we counted the quantity of water which has been melted. It was about 20% of the ice has been melted. So I think it is quite a good result to show the importance of these passive strategies.
So our guest this episode is Micheel Wassouf, who has over 20 years of experience in the design and research of low energy architecture. He's been a passive house designer since 2008, and actually became the first passive house building certifier in Spain in 2015. And he's a member of PHI's scientific committee. Currently, he's consulting different Spanish entities on EU energy directive implementation. And he's a founding member of the Spanish Passive House platform. He's also the co-founder and director of his firm, Energiehaus Arquitectos in Barcelona. And they lead in designing and teaching all about net zero energy buildings, or the nearly zero energy building standard. We're super excited to welcome Michael and to share his energy efficiency and renewable energy expertise. He's going to present some monitoring data and project details from the Carrob, a public school EnerPHit project in Barcelona. Thank you so much for joining us, Micheel.
Thank you very much, Prudence. I'm very proud to be here, actively part in this, I think, number 55 of your webinars. So it's also interesting for us because we also do something not so professional like you in Spain. We do also like each month a webinar, of course, regarding concerning pH. So nice to see you. And so would you like me to share my screen or okay? So I will.
Yes, thank you, Micheel.
Yes, okay. Okay, so I will try. I have 15 minutes. It's quite tough to go through to all this information for this project we have done some years ago. It's actually one of the maybe I think the first public retrofit in Spain where we done the project following the EnerPHit protocol. The Passive House Institute also is auditing actually this project. The building has been constructed 2 years ago, and we had the municipality also which organized the monitoring campaign last year. Unfortunately, it stopped with the corona pandemic, but I think we can see some nice, interesting results. You can see the building from it's originally from the 70s. So I suppose that in the US also you have similar kind of public buildings with no insulation and as you can see with simple glasses and very basic window components. So we started. We've done a blower door test. We normally do this also, of course, before the retrofitting of our buildings, and we had in this case really one of our worst results. We had a 17 and 50 value, which was quite very high value. You can see in the images, you can have an idea of all the performance of this building, which had a very low comfort scale. In summer, the teacher complained about very high temperatures, nearly clearly above 30, 35 degrees sometimes. Here you can see an analysis of the energy consumption of the building. It's interesting because this building is on the Mediterranean, so it's maybe 2 kilometers from the beach, and one would suppose that the heating is really not an issue in this building, but as you can see, it's 70% of all the energy consumption is driven by the heating demand. In this kind of buildings, there is no active cooling because it's a public school and there is no budget. It's politically difficult to install here active cooling devices. So what we've done is like the basic alphabet of passive house design solutions, like it's called 5 principles, plus of course the sun protection. So we neither hadn't the budget for making like inventing solar chimneys or something like that. So we concentrated on the I think you know that, like high insulation thicknesses, windows, passive house certified windows, etc. Here you can see on this floor a typical it was I think the first floor plan with the ventilation system. One of the biggest challenges in retrofitting this kind of buildings is the designing of the ventilation system. Because of lack of space, of course, these buildings, the architect in the 70s didn't thought, of course, of installing HRV machines when he designed the building. So you have a building with maybe 40 years of constant usage. So you have to struggle and really to find a place for these devices. And in this case, we designed like a semi-decentralized system with 2 HVAC machines per floor. You can see here a photo of the finished installation. We tried here in this case with textile ducts, which is supposed to have quite good comfort and air velocity, very low air velocity performance. So also They are interesting for maintenance because you can easily wash them in a washing center of the city. Next slide. Here we have section, and you can see the like the air tightness line, and as you may see, there is a small problem in this this design, because we couldn't act on the ground floor because of both limitation of the budget of the retrofit, which was from the beginning fixed, so we couldn't act everywhere, and also because of the limited time to do this retrofit, because the school is going on all the months through, and so we only could make the retrofit from ends of June till starting of September. So it was quite a tough schedule to perform in less than 3 months is the retrofit. So we were aware about this problem, and actually the airtightness test, the blower door test, I think the final one was 1.2, so we didn't reach the level of the EnerPHit, but nevertheless I think it is quite a very good result of this retrofitting. Of course, the summer case is a big issue also in this kind of usages in the Mediterranean, in this hotter climate or warm climate. So we have designed 2 barriers of exterior sun protection. We had fixed louvers, vertical louvers, as you may see here in this simulation. With this, we want also to not only to reach a very high energy efficiency, but also get an attractive and friendly character of the building. It's not so easy, of course, to just perform with exterior insulation with the attics system on the outside of the building if you don't consider architectural and aesthetic things. So it could be easily get a quite bad result aesthetically, and I think passive houses also has to have to get this high quality on architecture. So here we've made it's more in this case a theoretical comparison between a passive, the EnerPHit standard, and which is the green line, and then you see the blue line, which is the baseline, the actual Spanish building regulations. So just to see, it was like the overcost, the real overcost has been about 13%, and also the payback time, it's one of the ways to analyze this kind of maneuvers, was also 13 years. The total costs without the VAT, more or less 800,000 euros. I'm not aware about how many dollars, sorry, but I think it's easy to make the comparison. And at the end, it's typical in the retrofitting that you have surprises during the execution. So at the end, we ended up by, I think, 1 million of euros, and then the VAT, which in Spain is depending in retrofitting, it's 5% of the VAT you have to pay for the municipality. Some photos of the execution on the left hand. As we couldn't act inside of the thermal envelope and the inner side, so we decided to design a outside this black painting, airtight or airproof painting, which works, I think, quite well. The second photo, you see the testing of the adherence of the EPS insulation on this painting, which was not so clear whether it could work or not. And well, then some other photos. The lower photo of on the right hand, you can see the HVAC system. We tried to combine these the ducts with existing windows, so it was not so easy, quite challenging also to perform this for the installer. Here a photo of the floor of the first floor. During the execution, there were some surprises, some beams, concrete beams, which appeared unfortunately. So we had to change during the execution the design of the ventilation system. And even though the photo, I think it looks quite nice, because it was this idea to show to the pupil this kind of gadgets, of technical gadgets, which is part of their daily life routine. But I would not repeat this solution, because we had some complaints regarding the sound, the noise of these machines in some rooms. So it was like a compromise which you have to do. And of course, this was for us also a prototype, so we have quite a lot of learning effect. We had a lot of learning effect on this building. Here you can see monitoring before the retrofit. So it's very interesting to see how the blue line is the development of 1 week of in winter time. You see the outside temperatures between 7 and 15 degrees more or less. And you can see how a normal building performs. So the curve is really parallel to the outside temperature. No, this is very typically for these no insulated buildings with very high air infiltration. And then you can see the comparison with one typical week after retrofit. Actually, this was also in beginning of winter without the heating system, or let's say with the heating system switch off. So you can see also a week where we have 7 degrees, 15 degrees more or less, and you can see how constant the interior temperature has been between 20 and 22 degrees. Then we have a lot of data. Of course, the problem if you make monitoring, you get like millions of Excel lists, and you have to try to filter the really interesting ones. And this is from the last year's monitoring period. As I told you that unfortunately it ended up in no, this was before the retrofit. So you can see the purple line is indicating a very good quality of of the CO2 air quality of the inside, and you can see a clear difference between the typical winter months, which is between December till March, with quite bad concentration, high concentration of ppm during the classes, and then from April till June in these older buildings, of course, the user opened the windows, and in terms of CO2, it didn't have problems on that case. And then after the retrofit, you can see here also the development of it's a more more constant and horizontal behavior of the CO2 through all the months, which I think it's a good result. We calibrated the HVAC, the ventilation machines, so to be in like a range of 1,000 and 1,400. That was our aim. Then the user preferred to have lower ppm concentration, so therefore I think it's a quite understandable result. Then time out of this is before retrofitting, the time during the lessons during the lessons of the school hours. So you can see that, for example, February we had 80% of the time, lecture time, below 20 degrees, and then in June we had also quite bad behavior. This is before retrofitting. You can see here it's the same, but with another different kind of graph. And you can see in February, for example, we have to say with the heating system, nevertheless, most of the temperature has been between even 16 degrees and 20 degrees. So it's quite bad result now, I suppose. Then the summer months is April and May. It was not a problem for these months. And then June is a critical month, and before retrofitting, the rooms had quite a lot of days between 27 and 29 degrees. Some day with 30 degrees. Here is the comparison after retrofitting. So the green bars are the good performance bars, and we can see that it's a good result. Probably September and also June are critical in after the retrofitting. We have to say that the PHPP calculation already stated that the project was, let's say, above the 10% of overheating frequency. So for certification, it was mandatory for the end of certification, it was mandatory to have an active cooling system, because it was clear that just with passive cooling strategies in this kind of very dense occupied rooms, it was impossible to get into this 10% overheating frequency level. No, this, as I already told you, that this politically is not nowadays possible. So the municipality didn't want to install this active cooling system because of political reasons. You can see here also the development of the temperatures. I have two more slides. I don't know with the time. I think, yeah, we are quite okay. I have two more slides concerning the consumption. This first one is the electrical consumption. So of course, due to the mechanical ventilation, the red bar is after retrofitting, the blue bar is before retrofitting, and you can see that we increased the electrical consumption. So therefore, it's very important to work with very efficient HRV or ERV systems. In this case, it was a certified machine from Czech Republic, quite a good machine, and we could reach a certain balance with changing the lighting to LED lighting. So the final increase of the electrical consumption was about, as I see at the right, about 5% in the sum. Then, and this is the last comparison. This is the energy for heating, the energy consumption for heating during the 4 years before the retrofitting, and then the 2 years after the retrofitting, and you can see the difference. So we have an average of in the 4 years before retrofitting, an average of, you can see the numbers on the right hand, about 56,000 kilowatt hours per year, and then an average of 5,000. This is, let's say, for the main building, which has been retrofitted, because on the side there is also a kindergarten and also a small kitchen, and so therefore you have these different colors. So the color of the EnerPHit building is the light blue color one, and there you can see the change, the difference between these after and before retrofitting. So we had this decreasing of factor 10. So after the retrofit, the municipality is paying, or is consuming this building, in this building, about 5,000 kilowatt hours. So it's factor 10, so which is typical value we know in Europe for this kind of deep retrofits, starting from quite, of course, bad performance of the building, without any, or with very few insulation and bad passive house starting point. No, So yeah, I think I hope, I don't know, I didn't check my hours, so I don't know if we have passed this 15 minutes, or do we have time, or Prudence, you tell me, is it okay? I think this I'm this is when I'm ending. Is it fine, or
this is fantastic. Thank you so much, Micheel. And yeah, so what's going to happen now is that we're going to open the floor for some big picture questions. Until the top of the hour, and I know that it's very late for you, so I understand if after that you want to go to bed, but if you want to hang around with us for the after hours.
Well, I will try. If you see me like getting each time more relaxed, so just don't worry.
So we're going to have a lot of opportunity to talk further and answer people's questions. So anything that you didn't cover in the presentation.
I mean, 15 minutes. It's a lot of interesting things I could not tell, of course. Yeah.
All right. Well, we're going to look to Sean to curate or concierge our questions for us, and we'll turn it over to him.
Excellent. Thank you. Thank you very much. Great presentation. And we're going to kick things off with Tom Phillips.
Oh, hi. Yeah, I think you may have answered it already about the school year and when the school's actually occupied, and it looks like it's not occupied much in the summer when the main ban occurs.
I mean, the school here in Southern Europe, they close end of June till 10th of September. So that is, of course, the advantage of these schools, because they can avoid the really hot summer months. Of course, I don't know if in the US or in Canada you have probably different schedule of school.
It's similar, but for the most part. But it reminds me, there was some proposed temperature requirements for Spain, or maybe they're already adopted, because a lot of countries don't have a maximum temperature requirement. But I recall in last year or so there were some major problems with schools overheating. During heat waves, and there was some regulations. So does that apply to your project?
We have in Spain this regulation about 25 or 26, depending on the density and some parameters. And we have, I mean, we improved clearly in winter, but in summertime, more or less, this statistic, there is a slight improvement in summer performance, but it's not so clear. So of course, we are aware that this building really needs an active cooling system for getting in the comfort range. And we proposed this to the municipality, and actually we've done a post-project to integrate the design of the ventilation was already thought, so to integrate how do you say hydro box, I think it was a refrigerant with VRV system with a direct how do you say evaporate with a with a refrigerant system like Mitsubishi and this kind of. But the municipality decided not to do this till now.
Great, thank you. It looks like a nice project.
Yeah, thanks.
Thanks, Tom. And now we'll head over to Bronwyn.
Hey, Michelle, nice to see you.
Hi, nice to see you, Bronwyn.
I love your project, thank you. And I have to say, my COVID insomniac has been looking at websites of real estate, and I found I found Spain because I love Spain.
Okay.
Astounded at how many places, and I always do like a search, and they have to be passive house. And on the Spanish real estate websites, I found 333 passive house projects for sale in Spain.
Really? I didn't know that. Look.
Well, so I was curious. These what's so fascinating is a lot of them are, you have to buy them. They haven't been constructed. They've been designed as passive houses, or they're under construction. So I wanted to know what's driving this. Is there a big demand for this? And like, if so, what's the driver? How is this getting to be so amazingly well documented by these real estate sites? And
I mean,
can you tell us more?
We have some project developer in certain regions of Spain which are very, very convinced, and they do only passive house design and also certification. In some regions, it's more in northern Spain. So they maybe, because also of the weather, it's more extreme than southern Spain. And I think also the Passive House platform has done a quite good job in Spain the last years with promoting these standards. So this is of course also an advantage that in Spain we don't have any competitor. If you look the standards Passive House in other countries like Germany, I don't know, in the US or in France, you have a Maison Passive, or you have HQE, you have different energy efficiency standards and sustainability standards who are competing. So this is not the case in Spain. So therefore also Passive House is more dominant and is quite active in also the technology of construction in Spain till the last years has been quite basic. So there was a lack of, or let's say there was a demand for better construction quality, and therefore Passive House also had an easy job because it was like a synonym for German quality and good construction. So therefore it's not only energy efficiency, but also arguments like acoustic and things like that.
It's really impressive. I'm always loving the Spanish designs too. So I don't know. I put a link on the chat to everybody, and browse through it. It's kind of amazing to see what's going on in Spain. It's really fun to watch. Thank you.
Thank you. Great. I'm going to travel to Spain tonight. Haven't traveled in a year and look forward to it. So I'm packing my bags and going to Spain. Thanks, Bronan. I can't believe 350 passive houses on the market. That is a great stat for the night. That's great. Okay, next we're going back to Barcelona with Pablo.
Hello. Hi, Michelle. How are you?
Hi. Hello, Pablo.
I gotta say that Michelle, I met Michelle more or less 1 year ago, and the chaos was because of the lockdown. Because of the lockdown in Energiehaus, they were doing a lot of seminars, very interesting seminars, I gotta say. And we met during past year, so we will get in touch again because he knows a little bit about our frames that maybe here in this community they are getting used to know what we are doing with the polyurethane. But my question is related with the insulating materials. Is there any restriction for the schools for any particular insulating material because of some concerning of safety, or maybe, I don't know, toxicity? And the second one is related to windows. So what kind of current windows are being used? So they must be replaced. So let's say, who are competitors in schools?
I'm not aware about restrictions for any insulation materials in Spain or in the regulation. I'm really not aware. And regarding your second question, the windows frame we have used here in this school was PVC windows, because of course of economical reasons, because nowadays they are the most competitive on the economical level. So I think in Spain, at least, I have the idea that most of the biggest markets is the PVC market on the bigger projects like multi-residential or non-residential projects. So I don't know if in the US or in Canada you have also the same tendency, or is it more you have also other new materials, no, as I suppose? Or Pablo, you have also, you're working with new materials for windows, no?
Yeah. I think that Canada has a lot of wooden windows because obviously they have a big forest, so they have a lot of raw material to use. But this is why I'm joining also this community, to understand a little bit more about the Canadian and American market, the USA, because we find a really interesting market here. Thank you for your answers, and hablaremos pronto.
Sí, hasta pronto.
Thanks, Pablo.
Good night. I'm going to sleep. It's really late here.
All right, we've knocked off another European. We'll see how many go here. Thanks, Pablo. Appreciate it. And now we are off to Fit Mech John in Toronto.
Thanks, Michael. I really appreciated that. You touched on a subject that's hurt me on other projects before, and that's the noise of the solution. So I'd love to know if you guys did any measurements and tried to look at ways you might abate the noise, and if anything, what frequencies. How did you solve the problem, if at all?
Yeah, I mean, we had one machine which makes some trouble with the noise because it has to be changed during the construction, as I told, because there was some we couldn't put it in the previewed place, and it was too close to the. I mean, it's still there, and it's the user is not happy with that. So therefore, I say I would not do this again. We have measured it, and it was, I don't remember the values, the dBA, I think was maybe 60 or 50 or something like that on the top. And now, unfortunately, also the municipality, I mean, for pandemic reasons, they have pushed it on the maximum velocity, the machine. So it's even worse. We always tried to convince them to work with lower velocities. Even they would have got higher ppm values, but we had also problems with the original educational department, because they didn't want this solution, and they insisted in reaching at maximum 1000 ppm of CO2. So I don't know if you know, but the passive house accepts slightly higher values, not till 1000 or 1400 ppm or even 1500 ppm. So it's not easy to convince, of course, people from municipalities or from public workers who have their legislations, and they insist on that, and they are not very flexible on that.
So in retrospect, would fighting that have allowed you to abate the noise problem ahead of time, or would you just simply come up with completely different solutions to implement?
The original solution, I think, is okay, but I mean, maybe there was a problem of place, because the building was really full of stuff, and it was impossible to find any place, and probably there would have been we would have needed more budget to there would have been more solutions, surely, with a higher budget. But
yeah, your pictures made me have sympathy for the ductwork guy, that's for sure. Would have been a challenge.
Yeah. Also, the problem is the municipality, in smaller municipalities, because this was not Barcelona, this was close to Barcelona. They have quite very low budgets for yearly for maintaining and improving their school building parks. So I don't know if in the US or in Canada you have the same problem. You're from Toronto, so from Canada, but it is very, very difficult to convince municipalities to spend €1 million for 1 year for one building. For small, it is a municipality of maybe 100,000 inhabitants. So you need very convinced politicians to do this, and it's still now it's quite rare. I hope in the future it will change.
I hope so too. I think Prudence talked on using standards and getting them implemented. I look forward to that public fight. I think we must have it.
Yeah.
Thank you very much.
Yeah.
Thanks, John. All right, Scott Kennedy.
There we are. Okay. I just had a question on whether you could have, if you looked at whether the supply air could have provided the cooling you needed in the building.
It would have, I mean, we have calculated, it would have, as I remember, decreased about 1 degree the temperature. So I think we have made the calculation. So following the calculation, the maximum temperatures during the performance time of the building would have been maximum 26 degrees or something, 26.5 maybe, but it was about 26 degrees. So it was slightly higher than the legislation values, but I think 26 degrees it's okay for comfort temperature. Maybe not ASHRAE confirmed, but
right.
Okay.
So the other question I had was, if you did put a heat pump cooling system in, would you use it for heating, and would you be able to get the building right off gas altogether?
Yes, I think this would this could be a solution. Yeah, because I mean this building had a gas boiler which has been renewed, or a new one, like 5 or 6, 7 years ago. So they didn't want to change it because it was quite new. But definitely, I mean the heating demand was so almost zero, let's say. That's what also we have seen in the monitoring.
Thanks, Scott, and we'll head over to Zach.
All right, thank you. I've got some announcements for what's coming up next week, as well as the summit that's happening at the end of the month. First, I want to thank our sponsors who make all of this work possible. So our founding sponsors are 475 High Performance Building Supply, Baxtingui Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Stocorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are BR+A Consulting Engineers, Brennan Installation and Airtightness, Inotech Windows and Doors, and US Engineered Wood T-Stud. And this week, our sponsor of the week is Inotech Windows and Doors. They've made today possible, yesterday's Construction Tech possible, as well as the Passive House podcast. So a big thank you to Inotech.